Hello everyone. This lecture is about Carrier Sense Multiple Access CSMA protocol. At the end of this lecture, you may be able to understand what is CSMA, its purposes, and the types of CSMA with CSMA collision detection and CSMA collision avoidance. So let's get started. So actually, each node or the station, before making its transmission on the media, it senses the media before using it. By doing so, it reduces the collisions but not completely and increases the performance on the other way. That is, we can achieve better throughput by listening to the channel before transmitting a frame or the packet. So, the basic principle of the CSMA can be sense before transmit or listen before talk. So, the station need to sense the channel. If it is found to be idle, the station can transmit the frame immediately. If the channel is found to be busy, the station should defer the transmission of the packet. Defer in the sense just postponing the transmission of the packet, that is, you are waiting for some time, then the station will make its transmission. Let's go for an example. In this picture, some 4 stations are connected in a bus. Here, when a station sends a frame, it takes time for first bit of each frame to reach every station and to make every station to sense it. So in this example, A sends a frame. At the time T1, B senses the medium to be idle because B have not received the first bit of the A. So it will start sending its frame. Likewise, at the time T2, C found the medium to be idle because C have not received the bits of B. So, C also starts sending the frame to B as well as to the D. So, here there is a possibility of collision. So, you can say the possibility of collision still exists because of the propagation delay. Actually, propagation delay means it is the amount of time taken by a frame to make its physical journey from one station to the other station. So, larger the distance between the two stations, larger the propagation delay. Because of the propagation delay, there is a possibility of collision. So, in this example, in its worst case, the vulnerable time is a propagation time in this protocol. That is, A sends a frame at the time T1, but it reaches the D at the time T plus TP. TP is nothing but the propagation time, that is the maximum distance divided by the speed of the signal. Now let's see the methods which is used in this CSMA protocol. That is, there are 3 types of CSMA which is used to answer the above query, which is what the station should do if the channel is found to be busy, or what the station to do if the channel is found to be idle or the free. So let's move on to the first method. One persistent CSMA. Actually, it is a simple and a straightforward approach. The first step is it senses the carrier or the channel. If it is found to be idle, it sends the frame immediately with the probability of 1. Probability of 1 means we can make sure that the channel is free. That is, almost definitely the channel is free, so we can send the frame. And at the same time or some other time, if the channel is found to be busy, the station keep listening the channel until it becomes free. Once it becomes free, it send the frame immediately. So in this method, the possibility of collision is high because 2 or more stations can sense the channel at the same time to be idle and send their frame immediately. Actually, this protocol is called one persistent protocol because just now I said, because the station transmit the frame with a probability of 1 whenever it finds a carrier to be idle. Here you can see the behavior of this one persistent CSMA. It will continuously sense. When it is busy, it will keep on sensing, and once it found the medium to be idle, it start transmitting the frame immediately. So this is the flow diagram of this. Generally, this traditional Ethernet use this method. The next method is non-persistent CSMA. So, as the first step, it senses the carrier or the line. If it is found to be idle, it just send the frame immediately. Or if it is busy, the station will wait for some random amount of time and then sends a carrier again. So the main advantage of this non-persistent method is it reduces the chances of collision, because two or more stations may or may not wait a different amount of time, and they will retry to send again to send the frames. The demerit of this method is it reduces the efficiency of the network, because the medium will remain idle when there may be station with frames to send, which means it wastes the capacity of the link by remaining idle for much time. That is, the channel is not utilized. Here you can see in this diagram, in this picture, so it will sense if it is busy, it will wait for some random amount of time. Again it will sense if it is busy, again it will wait for some more random amount of time. But at this point the channel is idle. So here the channel is not being used, so it obviously reduces the efficiency of the network. So you can see in this flow process, if it is idle, it will send the data. If it is not, it wait randomly and then it will again sense the channel to become idle. The next technique is pre-persistent CSMA. Actually, this is what somewhat between the one persistent and non-persistent CSMA method, and this is applicable to the slotted channels. That is, the channel has some time slot with the slot duration equal to or it is greater than the maximum propagation time. So the procedure is, first it will sense the channel. If it is busy, it will wait for random amount of time. So if it is idle, it follows this procedure. That is, if it is idle, it will send the frame with the probability P. And if the next time or in the next slot is found to be busy, it defer or postpone the transmission of the frame with the probability Q is equal to 1 minus P. Again it do the same step. If the line is found to be idle, it goes to the step 1. If it is busy, it acts as though a collision has occurred and uses the backup procedure. That is, backup procedure means it wait for some time and retransmit the same frame. Again it wait for some time, it retransmit the same frame. Mostly the exponential backup is used. So you can see in this, so if continuously check whether it is busy, once it got idle, it will check for the idleness in the time slot also. If it is idle, it will send the data, or else it will wait using backup procedure. So if it is busy, it just wait until it becomes idle. If it is idle, when it is equal to the probability of B, it just transmit the data. If it is greater than probability of B, it wait for a slot. That is, it check for the slot, and the slot is busy, it will wait, and again it will check for the channel. If it is idle, again it will do the same procedure. If it is again busy, it uses a backup process as though collision has occurred. That is, this random delay ensures that the nodes which were involved in collision are not likely to have a collision at the time of retransmission. Next we will see about carrier sense multiple access with collision detection. Actually, it gives the algorithm to handle the collision. We all know that Ethernet network used to provide shared network, so there is a possibility of collision by stations sharing the medium. In this method, a station monitors the medium after it has sensed the frame, and to see whether the transmission is successful. If there is a collision, the frames are sent again. That is, the nodes continue to monitor the channel while transmitting a packet and immediately cease or abort the transmission when the collision is detected. So this technique is called CSMA with collision detection, or you can say as listen while talk. Now let's see the example. Actually, in this example or in this diagram, the first bit transmitted by both A and the C are involved in the collision. That is, at time t1, A is starting its bits of the frame. At time t2, C has not sent the first bit sent by the A, and so it start sending its bit of its frame, which propagate in the left as well as in the right direction. So the station C detect the collision at the time t3 when it receive A's first bit. So the station C will immediately abort its transmission. Likewise, the station A detect the collision at the time t4 when it receives the C's first bit. So the station A will immediately abort its transmission. So in this figure, A transmission is for the duration T4 minus T1 and C transmission is for the duration T3 minus T2. So at T4, A's frame is incomplete and it is aborted. The second picture gives a full graph of collision and abortion in this CSMA CD. That is, we need to see two things for collision detection over CSMA. If collision is detected during the transmission of the packet or the frame, the station will stop or cease the transmission and it will send a short jamming signal. Jamming signal here I have given. It is a 48-bit sequence signal, and that jamming signal is sent for short duration to ensure that all the stations, those who have not sensed the carrier, know about the collision has occurred. So after transmitting the jamming signal, the station waits for a random amount of time and then the transmission is resumed or it again starts the transmission. So to achieve stability, the back-off scheme is used. That is, mostly we will use the binary exponential back-off. That is, it is a technique which is most probably used in the Ethernet network to schedule the retransmission after the collision. That is, after the collision, the time is divided into discrete slot whose length is equal to 2 pi. So here the 2 pi means the minimum amount of time the station needs to listen the channel to detect for the collision. Here the pi is nothing but the maximum propagation delay in the network. So after 15 retries excluding the original try, the packet will be discarded and the node will report the error. So these are the description which I have said now. Now let's see the flow process of this. So when the packet is ready, when it is differing or postponed, which means if the channel is found to be busy, it has to defer the transmission. If it is yes, then it will wait for a backup time. That is, it will wait for random amount of time. Most probably we will use binary exponential backoff. If it is no, which means the channel is idle, it will start the transmission. If there is a collision, if it is yes, then it will send the jamming signal to all other stations which is connected in the same medium. And it will increment the attempts, and with the attempt in the sense the attempt of retransmission. If that attempt is greater than 15, then that packet will be discarded, which means that packet is an unlucky packet. If the collision is, there is no collision, which means the transmission is done, and if it is fair and good, then the transmission will be successful. And if there is during the transmission, if there is any collision, and if the collision is detected, the same procedure will be evolved. And this shows the energy levels of the channel. That is, the 3 levels of energy in the channel: 0, and then normal, and then the abnormal. 0 means the channel is idle. Normal means the station has successfully captured the channel and sending its frame. And if it is abnormal means there is a collision. Here the level of energy is twice the normal level. So actually the throughput of this CSMA CD is greater than the pure and the slotted Aloha, which we have seen in the last session. So this is an example procedure for the Ethernet CSMA CD which update the collision